So, good morning, folks. Thanks for joining Andy and I on this month's Oracle Database in Memory AskTOM Office Hours. In this session, Andy's going to talk us through using Oracle Database in Memory in its automatic mode. And with that, Andy, I'm going to turn it over to you.
Great, thanks. Hello, everybody. Yeah, we're going to talk about automatic in memory. That'll be our focus today. But of course, if you have any questions about database in memory, we'll try to answer those for you. And as Maria pointed out, I think there's a chat window where you can ask your questions, and we'll see what we can do to answer them. But as always, we kind of like to focus on a particular aspect of database in memory. So I'm going to kind of review automatic in memory and what that is, and also have a couple demos that we'll try to show you how it actually works in action. Hopefully that'll go well. We'll see. But you never know with demos. But with that, let's see. We can go down to the next. Oh, boy. This is 18C and 19C. So we have our safe harbor statement, but there's nothing going to be that isn't currently available for you. So last time we actually talked about something called automatic data optimization, or ADO. And I just had a quick review in here. And the only reason I really bring it up because ADO and AIM are separate features, if you will, but they rely on something common, which is heat map. And that's kind of the, under the covers is the kind of the secret sauce of AIM. I'll talk a little bit about that. But you know, one of the advantages of database in memory, and we won't go over kind of how database in memory, the fundamentals, as we've done that in many other AskTOM sessions. But since you don't have to populate the entire database in memory to take advantage of database in memory, unlike maybe ×10 or other in-memory databases, that's a good thing and a bad thing in the sense that you can pick and choose the objects that are available for analytic reporting and populate those in the column store. But then the Achilles heel of that is you have to figure out which objects you are going to populate. And so we have the in-memory advisor available. I talk about, you know, knowing your pain points in your application and how to try to analyze that. We have an implementations and usage white paper where I got to go over some of that information. But ultimately, one of the issues is how do you figure out what objects you should populate in the column store? And heat map is a great way for the database to help you or even do that for you, which is, of course, the topic today. So I kind of wanted to quickly just review the fact that automatic data optimization in 12.1 allows you to use policies at the segment level, not database in memory. That came in 12.2. But introduce something we call heat map. And we're going to talk a little bit about that because that's one of the big underlying technologies for both ADO and, of course, AIM. And so I kind of just wanted to do a little history, and that's kind of all I'll kind of say about that. In 12.2, which is what our previous AskTOM Office Hours session was about, which you can go back and take a look at the recording, we introduced the ability for ADO to work with database in memory. And we had policies defined, or you can define policies to automatically populate data in the column store, to compress it to a higher compression level, and to evict data from the column store. But that required you to create policies to do that. And so you could do that based on time, usage, but we had kind of set the table for the ability now to do this automatically. So you don't even have to create policies. You could just tell Oracle Database, gee, I want to run database in memory automatically. You figure out what to populate in the column store. And so that's the journey we're going to begin today with automatic in memory. So AIM, and that's kind of the shorthand to AIM, is automatic in memory. We introduced it in 18C. And really, the gist of it is to let the database, since it knows essentially what is being accessed and how it's being accessed, let it automatically populate the contents of the column store to let you leverage the memory that you've allocated, because memory isn't cheap. Typically Oracle customers aren't running around with terabytes of memory. And so how do you best use that memory and get the biggest bang for the buck. And so that's really, in a nutshell, what automatic in-memory is targeted at. It classifies hot data, intermediate data, cool data. That's kind of the three classifications. It actually just keeps track of all access, but as far as AIM is concerned, it's really concerned with what data is the most active as it becomes less active, and then what's the least active data. And it classifies that and then can act on it and act on the information. Both with data that's populated in the column store and not populated in the column store, obviously. So we could, so segments that become hot that aren't currently populated then obviously could be populated, and you could take advantage of that for increased analytic performance. Of course, there's a new parameter, because it wouldn't be Oracle if we didn't have parameters, but in-memory automatic level. So you don't have to make use of AIM. It is a feature that you can enable. It's not enabled by default. By default, you have the responsibility for alter table in memory or no in memory. But if you enable, and there are a couple of levels we'll talk about, then the magic under the covers can start to take effect. So with that, how do you enable it? I like the slides are easier to convey, I think, the information. I will do some demos. Again, if you have questions, feel free to ask. AIM obviously requires in-memory_size, the column store, to be allocated. So once the column store is allocated, then AIM is available. It does not require a heat map. You can enable heat map. 12.2 and above with database and memory will, again, the ADO portion of it. But actually, once you've enabled AIM, which I'll show you in the next slide, how you do that, heat map is used under the covers. So you actually don't have to turn it on for AIM to take advantage of it. And it doesn't require the advanced compression option. We kind of went over that with ADO, but if you do decide to enable heat map, which you can do as part of being licensed for in-memory, you don't have to license advanced compression as well. I bring that up because originally in 12.1, again, heat map was part of the advanced compression option and the ADO on disk segments as opposed to in-memory. So there are effectively 3 levels of in-memory automatic level. Off, which would be the default, so you have to enable in-memory, automatic in-memory. It isn't enabled out of the box for you, which is good because then you don't have a change in behavior unless you're expecting that change to occur. Then we have a low and medium level for automatic in-memory. Low, which will be triggered by a population failure. And so one of the things that I'll talk a little bit about that in-memory AIM is focused on is when the column store is under memory pressure. And so once the column store is either full, for instance, a population fails, an object you access fails to populate, or it's close to being full. In other words, it's like maybe 95%-ish. It's a little bit, it's not a hard and fast number. There are some heuristics that go on, but it's right around 95-ish% full. Then the column store is considered to be under memory pressure because an additional object that would be populated might indeed fail because there wouldn't be enough room. So then AIM will kick in. And so in the low mode, it's actually triggered by a population failure. And what will happen is the AIM will run in the background, part of the normal population processing that happens on a periodic basis. And it will evaluate the heat map for objects that are populated in the column store. And in the coldest segments, it will evict to make room for the failing object. Now, this is, again, a little, it's not deterministic in the sense that there will be times when if the object may actually fit, and so this will happen all in one shot, or if it can't guess the right object sizes to evict, the object that's failing on population may actually still fail, and it will have to get picked up on the second. And the reason for this is actually pretty simple. With compression, it's not entirely clear until we actually compress the object exactly how much space it's going to take in the column store. And so most of the time we get it right, but not all the time, and we don't guarantee that we're always going to be able to evict enough objects for the populating object to actually fit back into the, well, not back, but fit into the column store. So there is the case which is not the happy path. Happy path is you access an object, it's enabled for in-memory, we populate it, it isn't going to fit, we evict some other segments that are colder, and then that segment that we were trying to populate populates, and everything is great. There is the case, of course, though, that where we might not be happy path, and it might fail until the next access of that object. And so that's just kind of the low mode and how that works. That was a mouthful. All right, so hopefully that's clear, and I'll show that low mode in my demos because it's easier to demo because it's actually triggered by population, as opposed to setting the automatic level to medium. And if you set it at medium, when we're under memory pressure, then the background population processing will take over, and it will ensure that the hottest objects are populated in the column store, and the least active or colder, I hate to use hot and cold, but I guess that's the best analogy. The colder segments then will be evicted, and it will be managed based on IMCO cycles, so it's much more automatic than the low mode. There are ways to control that, which I'll talk about in a second, but that's kind of the difference. So the first one triggered by population failure. The second one is much more automated in the sense that objects will be automatically populated, and not necessarily the objects you might expect to be populated, because it'll be based on heat map and heat map statistics. So only the hottest objects will be candidates. And so how do you deal with where even though my object might not be super hot, I still want it to be populated? And so we'll talk about that. We good so far, you think, Maria?
Yeah, so far so good, although we did get a question that was asking about enabling AIM on-premise systems in 18C.
So, well, there you go. So let's just get that out of the way. So AIM, along with most of the newer performance features of database and memory, is only available on EXA in the cloud. And so the cloud where database and memory is available, so the extreme performance in the EXA cloud versions, and EXA on-premises. So normal non-EXA systems can't make use of AIM. So. Okay,
so I need to either have an Exadata system on-prem or be utilizing one of the database cloud services where I've got that extreme performance package.
Supported, yeah. Right, yeah.
Okay. So don't forget, folks, if you did want to try it out and you wanted to use it, then you can sign up for a free trial and try it out in our database cloud service using that extreme performance option. You get $300 for that free trial, which will last you about 30 days. So you'll have a good chance to be able to try it out and play with it. If you're looking for more information on getting one of those free trial accounts, you can go to oracle.com/tryit, all one word. You should be able to then get to the section where you can get that free trial information. All right, thanks, Andy. Otherwise, I think we're looking good.
Great. Keep clicking on the wrong, there we go. So enabling objects for in-memory or automatic in-memory. So obviously the object needs to be enabled for in-memory. So it has to be in-memory eligible to be populated. Priority set to none. So this is actually a good feature in the sense that, so if you have objects that you always know that you always want to have populated in the column store, then if you set a priority for population, then there'll be AIM, they won't be affected by AIM. AIM won't evict them from the column store. They'll basically be set aside, if you will, in a separate area that won't be affected by this addition and eviction of objects within the column store. So if you have certain objects where you know you need to have highest performance, but they might not necessarily be as the most active data, then setting a priority exempts you from the AIM policies or the AIM processing. And then in addition to that, if you have ADO policies you've created, then those objects, well, actually ADO policies that prevent an eviction, then those objects will also be exempt from automatic in-memory. So there is a way to control that and have the kind of the best of both worlds for your objects. So then what I was going to do is I wanted to kind of go over the processing of both. I kind of described a little bit about that with the setting of the objects, the lower and the medium setting for in-memory automatic level. But when we do set it to low, as I said, the triggering is when the object that you're accessing, you've enabled it for in-memory, it has a priority of none, you've accessed it, and it won't currently populate because there's not enough room in the column store. So then we're under memory pressure, and what's going to happen, and again in the background, we're going to evict one or more segments and hopefully populate that object in the column store. And that's basically the same thing I already described, but I wanted to have it written down in case I tripped up on the processing, simply because then we have the medium part of it. And so medium is a little different. Medium is much more automatic than the low is. And so now with the memory or the column store under memory pressure, during an IMCO cycle, and the IMCO is the in-memory background process that's controlling population. And once that runs roughly every 2 minutes, but on a periodic basis. And so it actually picks up now on the monitoring of the column store while it's under memory pressure. And what it will do is take a look at the heat map information, plus actually other heuristics about the accessing of the data, the objects themselves. And what it'll do is it'll evict colder segments and populate hotter segments. And it'll do this, basically there, in the picture I had, there, right here. So we have, it basically will classify in a kind of basically a list, a one-to-end list, hottest data, intermediate data, and cool data. So it's the hottest data, whether it's in memory or not, that it's going to want to populate into the column store. The intermediate data it's going to leave alone, and the cold data will be eligible then to be evicted until, of course, it can get all of the hot data that's most active that isn't currently in the column store, but that's, remember, enabled for memory, populated. And then the column store will kind of get to essentially a steady state until heat map changes require that it pick that up again and bring in additional hot segments. So hopefully that makes sense. There is an ability to manage the heat map, what AIM considers in the heat map. And so it's called AIM stat window days. And I think I have a whole section on that. So what I'm going to do is actually, I'll leave this as kind of a section for heat map. And I think what I'll do is we'll launch into the demo, since we've had enough PowerPoint, and so maybe we can see how this thing actually works. And then we can come back and talk little bit about the heat map heuristics and how we decide what objects are going to be populated in the column store, and then how you can take a look at that as well. So with that, I'll flip over. I hope that window is big enough to be able to see.
Yeah, looks good, Andy.
So what I've already done is I've already set up the column store. I'll show it to you in a second, what objects are populated. And what I have here, I just listed out the attributes of the objects that I have enabled for in-memory. Except I have actually, these are actually all of the objects in the star schema benchmark, because our normal line order table, which is always really large, I just disabled it because it just gets in the way. It's so large that then it's too hard to show all of the objects in the column store and the movement that can occur. So I actually disabled that. Notice though that I have one object, supplier, with a priority of high. And so I did that. So that object is basically exempt from AIM. So it's going to stay in the column store no matter what. It's until we do an alter table no in memory or the instance were to go down. So I'm purposely exempted the supplier table from being eligible. Everybody else, though, is enabled and has a priority of none. So they're all, based on heat map, eligible to be populated in the column store. So kind of that gets the basics underway, out of the way, but I did want to show, so what we have currently populated, I have the two supplier tables. Basically, I have the star schema benchmarked, and I had to make some more objects, so I just messed around with existing objects and duplicated them, and so no big deal. But what I have is the two supplier tables, customer, date dim, not huge, but then big part I added, it's much larger, just so that I got to be able to fill up the column store, and so I made a couple that definitely would do that. So we want to be able to trigger a population failure, and so that's kind of the table that I've set. And then our current IM usage is roughly 70 megs, and I've allocated about 40 of those. And we, of course, we have our metadata pool as well. So that's kind of the state we're currently sitting in. Now we'll cross our fingers, and all the rest of this will go right. But so what I'm going to do is I'm actually going to go ahead and access another table that's a copy, essentially, of big part, and I called it big two-part, a lot of imagination there. And since it's enabled for in-memory but a priority of none, once I access it, then it's eligible to be populated in the column store, and we should have enough memory to populate that. So again, we're crossing our fingers, because we'll talk a little bit about heat map, but I didn't preload heat map, so I'm hoping that it's going to cooperate. And since we weren't under memory pressure, the AIM hasn't kicked in yet, and so yes, we get big two-part populated, everybody's happy. Take a look at our usage. And now we're creeping up right to the top, or the fullness of the column store. We've used up almost all of the column store. So effectively, we're going to be under memory pressure, because we're probably not going to be able to populate any of our other objects. If you look at, they're all basically 1 meg, 5 meg, 30 meg, so it's probably not going to go in. So we've kind of set the table. Remember that this is just we're just doing a demo here. In a real world situation, you have lots of activity going on. All of this is happening, multiple concurrent processes, and so this is all happening in the background under the covers. AIM is managing this, Oracle Database is managing this, but we're just taking the simplest path just to illustrate how this works. So it's certainly not a one user only kind of environment, but I just want to make sure everybody remembers that this would actually be on the fly happening. Objects could be being populated and evicted based on heat map statistics on a more frequent basis than what we're doing here. All right, so now we're going to see what happens if we try to populate another object that, again, is enabled for in-memory, no priority. So we know suppliers are going to stay there, but we'll see what else happens. And again, we're going to cross our finger. I'm going to cross my fingers. You guys probably are expecting it all to work, and it worked. It's worked multiple times, but we'll see. Because again, I didn't load heat map, and we'll look at heat map in a minute, because heat map's an interesting conversation as well. So I'm going to select selecting part 2, and so we'll see what happens.
So Andy, before you look, would you be able to predict who's going to be evicted?
Oh, good. I could only predict who's going to be evicted if I knew the heat map information about the objects populated.
Okay, so that would be where you go look.
In other words, the coldest segments or objects would be the candidates to be evicted.
Okay.
And again, since I have in the past when I've done when I'm experimenting, but today I actually didn't load the heat map so I could make it more deterministic. I just kind of hanging it out there, just seeing what's going to happen.
Okay, maybe we should have put money in. We should have all picked a horse in this race, but that's all right. Go ahead. Yeah.
Yeah. So it just time and such just precluded, unfortunately. And to be honest, you wouldn't do that normally anyway. So did we make it? Oh, it made it in. So oh, sorry. But it did do something different than I had in my other demos. So we have 6 objects here, but notice that one of these two, big part is now gone. So it decided that it was the coldest, and it does look at sizes. So it knew that if it evicted that, it was going to gather more space. So that's the guy that went away. And part 2 was populated, so yay, it worked. And 2, it said that big part was colder, and so it went ahead and evicted it. So it did that automatically. And now actually, if we look at, do a couple of things, but if we look at our usage, we actually now have quite a bit of space because it picked the 30 megs, so we could populate a bunch more without having to evict anything. So technically, we're now not under memory pressure because we have quite a bit of space available in the column store. So now we would go back to normal processing. And this is kind of how this works in low and medium mode in memory, is once if it's able to evict segments, and remember, it's not going to evict just part of a segment, it's all or nothing. And so it's going to evict the segments that seem to be the least beneficial, and so it could free up quite a bit of memory and bounce that line between being under memory pressure and not being under memory pressure. But
so Andy, can I interrupt with a quick question? Just because I think you may have chosen your words very carefully there, where you said that it's evicting segments. Yes. And it's an all or nothing decision. So if I had a partitioned table, would I be able to then keep the warmer partitions in the in-memory column store with the older ones potentially getting evicted to make space, but not the entire partition table?
Yes, it's based on segment. Yeah, exactly. And that brings up a good point, because with ADO, and one of the examples we used in the ADO session was partitioning, and kind of the case where you have rolling window partitions over time. You might want obviously your hottest partitions or your newest partitions, which would typically be in most environments the hottest ones, in the column store, and the colder ones evicted. And so we created policies for that. But in this case, we could do that more heuristically in the sense of actual usage. And so, yeah, that would be, so partitions, subpartitions, materialized views, and obviously tables are going to be treated in their entirety. And so it's an all or nothing. I hate to see, we spend so much time talking to people about the fact that the column store is not a cache, it's a store. So when you alter an object to be in memory, we populate that entire object so that we can scan without having to, being able to take advantage of the in-memory part of having that object populated in columnar format in memory. But we're going to evict the entire object. And so yes, this works just as well at the partition level as it does at the table level or even the subpartition level. For AIM, as long as the priority is set to none, it doesn't matter what the object actually is, as long as it's eligible for in-memory population, and it can be populated or evicted. So what I thought was an interesting question next would be, well, so how do I figure out what actually happened, especially if I'm not sitting here watching it? And so, of course, it wouldn't be Oracle if we didn't give you views into what's going on, just like we do with the scheduler and some of the other features of Oracle database. And so there is a couple of views, and I created some scripts so I wouldn't have to type too much, and of course I just messed that up. But AIM tasks, that would have made more sense. So this actually view, and shoot, didn't echo this. So there's a view called DBA in memory AIM tasks. So that's pretty self-explanatory in the sense that it will record tasks that occur within AIM, that AIM initiates. So it actually, AIM will be looking constantly within that IMCO cycle for things that it needs to do, but it'll be, once it's triggered, or once a task is actually created, or a set of tasks, I should say, it will be recorded in this view, DBA in-memory AIM tasks. And here we see on today, July 24th, last time I ran this was 2 days ago, but, or last time an AIM task was created was 2 days ago, we created a task. And so there are also subtasks associated with that that actually do, or tell us what work was actually done. So let's take a look at that. So AIM details. Oops. Man, I just cannot win on the typing today. There we go. So I actually put just a where clause in here, so we'd only have to look at the current task. So I'm going to put the task ID. And the query is very, very simple. Again, DBA in-memory AIM task details. So parent-child relationship between AIM tasks and AIM task details. So we notice that the task ID associated with our initial task is 94. And so let's take a look at what happened. And now we can see that it took no action except that it evicted our big part table. And so you can go back historically and see how AIM is working over a period of time, if you're interested, to see what's being evicted and what isn't. And then you might go look at the heat map heuristics to see how much activity is actually occurring. And we'll talk about that in a few minutes. But the gist of this is that you can see then what actions are taken and kind of have an idea of what's going on under the covers.
So Andy, how long is that history kept around for? Sorry, you may have answered this, but I was...
No. Since it's a DBA view, as far as I know, it's kept forever. I don't know if there's it's a good question. I don't know if there's I don't think there's a purging. There is. I don't know that for AIM tasks there's any purging available. I suppose there is. Actually, that's a good question, and I'm not sure.
That's right. My guess is it'll follow the same rules as most of our dictionary history, which is 30 days unless otherwise specified, that we will keep it around for at least 30 days unless otherwise specified. It may also be the case that if we're not doing too much, as you said, that it settles down after a while, that we'll keep the history because we haven't, maxed out the space limit that may be on it. So it's possible that we'd keep it forever if we're not very actively populating and evicting.
Yeah, good question. I'm not positive. That sounds reasonable, but hey, I'll have to figure that out, and that might I might slip that into a blog post, which I'm thinking about doing another one on AIM. We actually did one, hard to believe it was a year ago, I did an AIM blog post, which actually talks a little bit about some of the same things here. But we're going to go into a little bit more detail than that blog post did. And so I was thinking of writing one up on the medium aspect of it, which is, like I said, kind of hard to demo, but could be, I think, would work in a blog post, and maybe I'll add that in there just as kind of more information. But yeah, I guess it would just be whatever the Oracle database for any of the DBA type views would be. And to be honest, I never thought about it. Good question. So that's happy path, right? We not only did we not have enough room, we were under memory pressure, but then when we accessed the object, it was actually fully populated as in essentially the same processing as the eviction occurred. Now, if we had been right at the tip, it's possible that our object might not have been fully populated because it might not have fit. We might not have evicted enough, had enough memory freed up from the eviction or evictions. And then it would get populated on the next access, assuming that it was still hot enough from heat map heuristics because it's still looking at how heat map works. And in the medium level, remember all this is going to happen automatically under the covers, so it's not dependent on a population failure to occur. And I think that that kind of works for that, unless there's any other questions. And what I was going to do is I wanted to visit a little bit more about and talk a little bit more about how heat map's working under the covers, because heat map is very integral to how AIM works. And so I thought it was worth talking a little bit about that, because I think actually it's one of our more useful underlying features. Personally, I think even without AIM, just in general, I think EMAP's very valuable, even on the disk segment aspect of it as well. So I thought I'd visit that a little bit. As a review, it's just classifying data, hot, kind of intermediate or less frequently accessed, and dormant or cold, and the least frequently accessed data. And so it's actually, heat map itself is tracking access both from a full table scan aspect and from essentially an index or row ID type access. It actually differentiates the access. Not that we care, because with database and memory, we really only care about full table scan access, but heat map is more comprehensive than just that. And so what I have here is I got a little wordy, but I wanted to kind of spell this out because some of the documentation were not as specific. And I thought it was useful in my speaking with the developers and experimenting with this to kind of let you guys know how the intent and how it's supposed to work and what's going on, so it's more explainable than just saying, well, heat map tracks segments. And so it does capture it in memory, and then it persists on a periodic basis. It flushes it to disk. So heat map isn't transactional in capturing. It's actually on what I call a best effort basis. And so it is possible that if the data in heat map hasn't been flushed and the instance, say, were to go down, that particular day's heat map tracking data could be lost. And it's basically not a big deal in the sense that we're looking at heat map data across a fairly wide or large date range, basically trends, if you will, rather than actual specifics. And so in order to keep the overhead very low of tracking, we only actually flush it by default once a day. You can actually do that manually if you want, and I actually have that at the bottom. So if it's more critical to you, you could either do it manually, or you could even set up a scheduler job if you wanted to do that. The other kind of takeaway for heat map is that the data is, since it's in memory and on disk or DBA segment, it's actually the views wind up unioning that data together in essence to get to give a picture of the current status of the data. So you actually can still see the data that hasn't been flushed yet as part of the segment views. And I'll show you what those are in a next slide. The other kind of interesting thing that I discovered was that an individual session, when it accesses objects, will trigger heat map counts, but it actually won't flush to the in-memory heat map segment data. This gets a little complicated until you either exit the session or on a periodic basis of every 10 minutes. Again, thinking that we're trying to make the heat map tracking the least intrusive as possible. We don't want it to be transactional in the sense we don't want it to interfere with your other application processing. And so it is, again, best thought of as on a best effort basis. And I think that's kind of the point I wanted to get across with the heat map, the data tracking within heat map. And then I wanted to talk a little bit about how AIM makes use of heat map. And now we're back to, I showed you earlier this parameter, AIM stat window days. And so why this, I think this is actually kind of interesting, and why this is important is it's entirely possible that with different levels of workload, in other words, you might have weekly or even nightly processing that could artificially inflate heat map numbers for certain segments, if you will. And so you can actually set the stat window to a smaller number of days to try to avoid having that occur. In other words, say if you did weekly, daily is kind of tough because it actually defaults to a day. Although I actually talked to the developer, and we're talking about making that, possibly making that more granular than even a day. But the point being that if you said, for example, if you had weekly processing and that inflated certain objects to very high heat map counts, but the rest of the week, they really don't need to be in the column store, there's a way around that in the sense that you can reduce your stat window to a smaller window so that those aren't considered across the rest of your normal processing. Same as for, say, monthly processing. So that's kind of was the motivation. For the demos that I did, I'll show you, I actually set it to 1 day because I didn't want my previous experiments to get in the way of the experiment that we were doing today. I don't know whether that was reasonable, but I had a couple of cases where I inflated the counts of certain objects, and I was having trouble getting the ones I really wanted to have in the column store. So I thought it was interesting. And so I just kind of point that out, is that the AIM consideration of heat map is based on a window. And then you can actually set the window, that 31 default, with a couple of APIs, DBMS in-memory admin. So you can actually control that by setting that in PL SQL. So kind of a footnote of information. And then the views that the AIM uses, and then actually that heat map as well uses, I've listed them. DBA heat map segment, and I'll show it to you in a minute. The problem with DBA heat map segment is it doesn't show you the counts, and so it's not easily you're not easily able to see what ADO or AIM would then base the its decisions on. And so there are two other views. Underscore sys heat map seg histogram, which I've talked about in some of my ADO information, and then AIM has its own underscore sys AIM seg histogram, which only requires in-memory size to be greater than 0. And the reason is because AIM doesn't require heat map to be enabled in order to make use of it, whereas ADO does. And so the first two require heat map to be turned on. The last one does not. It only requires that database and memory be enabled. I've also talked to the developer. This has been a pretty good exercise because I've had a chance to talk about some of the AIM aspects, because there are some AIM changes coming in future releases, and we're on of the opinion at this point that we're going to change these two from underscore. Developers kind of have the sense that nobody's going to look at this stuff and that it should be internal only. But we're going to make those full-fledged views. That's the intent. I can't promise it, but that's our intent fairly soon, is to make these just regular views that will be then documented, because they are useful, I think very useful. I use them all the time when I'm looking at both ADO and AIM. And to be honest, I think you would too, if you were trying to figure out what heuristics were being used to make determinations of objects, either kicking off policies or evicting or populating objects in the column store with AIM. So that's the kind of the description of those views. And so I've used those in my demo. And so let's take a look at what our current heat map looks like. And what I've got is 2 scripts. The first one I'm going to run is DBA heat map segment. And so notice that what we get is a single row for each object that I've accessed in my schema, since those are the only things I'm dedicated for this SSV schema. You might see many other segments or owners if you in a real system, but notice that all we're getting essentially is dates. So we get the last date of when the full scans occurred. But there's more going on under the covers for ADO and AIM. And so this view, while somewhat useful, isn't, my personal opinion, isn't all that useful because it doesn't give us any counts. So what I've done then is shown our heat map seg histogram. And there, notice that there are other columns, but the one we care about is the number of full table scans. And obviously that is important for database and memory. And so notice that now we get multiple entries, one for each day. Again, remember this is essentially daily based for heat map. And we see that for a given day, we have, for like say date dimension, we get the counts and the number of times that this data has been accessed by applications. And so based on our window, we might only consider, in our case, as I said, we only considered the current day, but maybe you have 30 days or a week. So you might consider multiple days worth in its totality for the number of counts. And so I have that across all of them. And that's this segment level. There's also, actually I didn't mess up if I did. So there's also an AIM heat map, the third view that I talked about. So I have that separately. And the interesting thing about this guy is it only lists the objects, we had all of them here. It's only going to list the AIM eligible objects. So you can kind of filter out the objects that would actually be affected by the AIM analysis for heat map, which is kind of nice. And then if you wanted to add, since it's SQL, if you wanted to add your windowing, say maybe you're only really considering 5 days, you could further take the track time and subset that down to just the last 5 days. So you could see exactly what AIM is considering for heat map counts. Notice our big 2-part has got a count of 10, and actually that was from the 22nd, and I had part 2, 12, which is why I kind of said, well, I won't preheat it, I'll just let it be the current day. So it would be like, today would be just the 24th. So I could have put a where clause predicate that said, just give me the current day's information. And then the only other thing I was going to show for that was you could actually programmatically do that, because it is obviously, not obviously, but you can actually then use the DBMS in-memory admin, get the parameter, and you can see that I actually set my stat window to 1 day. And then I have an example here where you might set it to, say, 10 days. And again, the default's 31 days. So you could adjust that, and you could do it once and leave it alone, you leave it at the default, or you could adjust it constantly if you wanted to. And in addition to making these views real views as opposed to underscore views, we're also considering doing the same thing as we do with the scheduler. We allow in the scheduler to have less than a day on scheduling. Unfortunately, we can get down to the minutes or seconds by doing the proper division, the 24 hours, 60 minutes, and you can do the division. That's probably how we're going to set this up as well, so that you could actually have the window to be less than a day. You could maybe say on an hourly basis, consider the heat map window and what should be populated, what shouldn't be. So we're talking about making that an enhancement, maybe either in it's hard to say whether it'll come out in the next release or maybe even in a patch for it. So I think it would be useful having taking a look at this in some more detail, and also in some feedback from customers. So I think that would make more sense, but currently it's on a day basis. So that's how you can tell. And then you can obviously set it with the set, and then you could filter that into your heat map view, so you could see what AIM is actually looking at as well. All right, so that's, I think, what I wanted to cover as far as AIM, the different levels, heat map and its input into the AIM decisions, and how that works. What do you have anything, Maria?
Well, I certainly want to add my vote for making those views public or documented, just because it's incredibly useful. Because it would have been a way for us to have perhaps our wagers that I was talking about, as we decide what's going on. If you looked at that information, you'd have a very strong indication about who might get evicted and who wouldn't, just based on just the full table scans alone. It's a nice indicator about which aspects of my workload are useful.
Right. And then with a lot of things in Oracle database, if it's there, people will find them. And it's, if you do, you can query and see the views. And so I think we should just make them, and I think we've got agreement to do that. People, sometimes the developers think that there's things that they don't realize how sophisticated our customers really are at times. And so, but the good thing is, it means people want to use it. And so I think that would be, yeah. So, but even if it in its current state, it's still queryable. You're not going to violate any licensing that I can think of.
No. I'm sure you're fine. It's just knowing that they're there and knowing what names they are and the columns that are in it is incredibly useful.
Exactly. And as a closing note on this, I tried to list out all the places that have information about AIM, and it's spread a little bit over a couple of different manuals, but and it changes the section in 18C versus 19C because we obviously add stuff. But these are the areas where you could go actually look at all of the what I found, other than our white papers and blogs, information in the documentation about AIM and the different parameters, the settings, and the descriptions of how it works. So I wanted to add that in there so that it would be an easy reference.
Oh, cool. That's very useful. We've mentioned the blog a couple of times, and I believe on one of the lower slides, you've probably got details on that. Yeah.
Yeah. So on our blog, we have the regular blog on the left side where I post technical articles and try to get some information about what's going on. And I guess I'm going to have to, if it's only 6 weeks away, I guess I'm going to need to put an open world blog out there and kind of start advertising our sessions. And then even though it's Oracle, it's a little hard to find, which is why I put if you choose the menu and I put a nice arrow circled, our resources, and that's the URL here, what I consider kind of our portal of information. And if you go to that page from the blog, you can see AskTOM sessions, all of our white papers, all of the important information. Obviously, some of it's on oracle.com as well, but I kind of try to tie it together to give you an easy way to go say, oh, I want to go explore what that feature was. Let me go look what they talked about in the AskTOM session, or maybe I want to go figure out how to run a SQL monitoring report. Anyways, all those kind of information that we've gone over, I try to make kind of a central area where you can go get that information. So yeah. And again, since it's a little hard to navigate, it's not obvious where this page, the page on the right, is the resources page. So it is available, and I just kind of try to point it out at this point. So, and then obviously at the very end, I put here just kind of the basics, oracle.com, but our YouTube channel where we will have portions of our demos and other information. Obviously our AskTOM office hours that you get the emails from, and then all of these sessions are recorded, so you can go back and look at what we've done in the past, and then our own in-memory guide and the documentation. So there is hopefully quite a bit of information available. If not, you can always email me or tweet, message me. More than happy to answer any of your database and memory questions. Sometimes I'll even answer non-database and memory questions if I know the answer, or I'll be more than happy to point you to people that do know those answers. But anyway, that's all I had.
Well, thank you very much for an awesome session, Andy. I learned a lot about how to turn on the whole automatic in memory, and actually it's not as scary as I originally thought it might be, right? I mean, you always have that concern. You hear about an automagic feature and whether or not I can influence it or not, and knowing that I can put a priority on an object to keep it in the column store so that it's not going to be impacted by the automatic algorithm, but maybe let it take care of everything else, is actually quite a nice combination of the features, so that I can have control where I need to, but not over everything.
Yes, yeah, thank you.
So folks, if there are any other questions before we wrap up, please don't hesitate to add them to the chat or let me know and I can unmute you and you can ask your question live. whatever you prefer. Otherwise, we want to thank you so much for participating in today's session. As Andy said, all AskTOM sessions are recorded, and we will make those videos available to you through the AskTOM website, but also on the Database InMemory YouTube channel. A lot of nice thank yous coming in the chat for you, Andy.
You're very welcome. So.
And compliments on the session, but no question yet.
I must have taken care of all the possible questions ahead of time or through the session, which is a good thing. So yes, and thank you everybody for joining us.
Yeah, we really do appreciate it. We hope you have a great day. Thanks, folks.